Welcome to Spring LIB.
All right. So for this problem, we have a capacitor, and we have a slab inserted between the two plates. So we know the parameter, the area of the capacitor is 115 centimeters squared, and the separation of the two plates D is 1.24 centimeter, and it is connected with external battery V. So V equal 85.5 volts. And we also know the thickness of the slab, B, is 0.78 centimeter. Besides, we know the dielectric constant of this slab is 2.61. So for this problem, for part A, we want to find out the capacitance of this setup. So to simplify this setup, we can actually treat it as series connected capacitors. So for part A, so for C1, C2, for C1, this is filled in with air, and for C2, this is filled in with this material with this 2.61 dielectric constant. So then the total C will be equal to C1 C2 over C1 plus C2, right? So C1 has formula epsilon naught times A over D minus B, because the thickness of the part without the slab is D minus B, okay? And for C2, it should be kappa epsilon naught A over B, all right? So now that we have the expression for C1, C2, so we can calculate the value for them, and then just plug the values into this expression. We can find out the solution of C. So the value I found for C is 40 picofarads. And for part B, we want to find out the charge stored on the surface of the plate. So now that we have the capacitance, so according to the definition of the capacitance, we have the charge equal to C times V, where V is just the voltage across the battery. So so V is over here, and we have C. So we just plug in the two numbers. You can see that this is equal to 1.15 nanocoulombs. And for part C, we want to find out the we want to find out the electric field in the air part in C1 actually. So because C1 and C2, they are actually connected in series, so they have the same charge on them. Okay, so the charge is just equal to 1.15 nanocoulombs as we found previously. So the potential difference of C1 will be equal to V1 equal to Q over C1. All right, and we have expression for C1 over here. So the electric field E1 will be equal to V1 over the thickness of the C1, which is D minus B. Okay, so after simplifying, you can see that this equal Q over epsilon naught times A. So the value is 1.13 times 10 to the fourth volts per meter. Okay, and for part D, so similarly, we want to find the electric field E2. Firstly, we need to find out the potential difference of V2, which is equal to Q over C2. Okay, and E2 similarly equal to V2 over V in this case. So this equal Q over kappa epsilon naught A. So V2 is just over here, and you have expression for C2. So just plug this expression into this V2, and you can obtain the expression for V2. And use this V2 divided by B, you can obtain this expression for E2. Okay, And and the value for E2 is let me see, it's 4.33 times 10 to the third volt per meter. Okay.